Welcome to Alpha Space. Today we'll be starting a series on the topic set theory. I hope you are ready. Ready to bring out your books out here with your books and your pens and every materials you need. Because by the end of this series, I assure you that you'll be able to solve questions on set theory and also to smash your exams. So what is set? A set is a well-defined collection of what objects or things. And the objects and those objects or things are referred to as what elements. Say it again, a set is a well-defined collection of objects or things, and those objects or things are called elements. For example, a set of colors A is equal to red, blue, and green. You can see this is how a set looks like. Now, when we say a set is well defined, we mean one should be able to determine whether an element or thing or an object or thing belongs to that set. For example, a set of colors that I've stated, red, blue, or green, red, blue, green, red, blue, green. I cannot put shoes, I cannot put shirts into what this set. So a set is well defined, meaning what one should be able to determine whether an element or an object belongs to that set. So we all know from this that a shirt does not belong to this set. A shoe does not belong to this set. Because why? They are what set of what colors. So, in simple terms, or summary of what I just said is when a set is well defined, meaning that set should be specific. Now, there are things I would like us to note about sets. Three things actually. The first one is the elements of a set must be enclosed with what curly braces. These braces or curly brackets or braces, curly brackets or braces. So we are not allowed to use parentheses, and we are not allowed to use what? Square brackets. Only what? Curly braces. So curly braces are the only acceptable ones. Are the only acceptable brackets used to enclose the elements of the set. The second one is after each element in the set, it should be separated with what commas. For example, I separated them with commas. If I have removed these commas, all these elements will be regarded as what? One element. So they will not be regarded as a separate element. So after each element of the set, they should be what separated by what commas. Lastly, the name of the set must be what? A capital letter. And this is the name of the set. So I cannot have a set of small letter A equal to maybe red, blue, green. No. This will be what? Totally wrong. So only capital letters are used to name sets. Now, we're looking at the methods of describing or representing sets. The method of describing or representing sets. There are three methods we'll be looking at. The first one is your roster method. Your roster method. The first one is your roster method. Now, the roster method, in this method, the elements of a set are what? Listed out. So the elements that make up that set are listed out. So this set we have here is an example of what? A roster method. So a set A is equal to red, blue, green. I've just listed out the colors of that set that make up that set. So this is a perfect example of what? A roster method. The second one we have is your set builders notation or rule method. You can call it your set builders notation or your rule method. So I'll write rule method instead. But it is generally known as what set builders notation. Now, this is a mathematical shorthand which is used to describe a set by specifying the properties that the members or the elements of that set must satisfy. I'll say it again. This is a mathematical shorthand used to describe a set such that by specifying by specifying the properties that the members of that set must satisfy. So the general form of writing a set builder's notation is what? A is equal to x colon property. Or you can write it as what? A equal to x what? Property slash property. So these are the general forms of what? Writing your set builder's notation. Where your colon or your slash is read as what? Such that. Where your colon or slash is read as what? Such that. So, if I want to read this, I'll say a set A is a set of all x such that the property. I'll say A is a set of all x such that what? The property. So these are the various ways of what? Of representing set. And lastly, the last one is your Venn diagram. For your Venn diagram, it is just the best way of visualizing sets. So the best way of visualizing, if you want to visualize form of a set, your Venn diagram is a method of representing it. So let's look at examples concerning all of length in order to understand them better. So we have our first example. By using the roster method, describe the following sets. The first one is a set C, it's a set of all x, such that x is a day of the week. The second one is B, it's a set of all x, such that x is an element of what? Integers. So the Z here is what? Integer. Where x is greater than or equal to 5 and less than or equal to 14. Lastly, we have B, the set of all x, such that a quadratic equation. So, as we've read this, let us answer it. Write it here, solution. The first one is the set of C is a set of all x, so that is what is a day of the week. So, because we have is doesn't mean we are referring to only one. What it means is, as we stated from the definition of set builder's notation, you can see they are using the set builder's notation. So a set builder's notation is by specifying the property that a member or element of that set is what is carrying. So by specifying the property of a member or element of that set. So a member of the element or the element of this set C is what? A day of the week. So therefore, the other members will be days of the week because sets we call must be well defined. So we can be able to determine whether an element belongs to that set or not. So therefore, the answer to this will be what? C is equal to what? I won't write everything, so I don't want to waste our time. Monday, Tuesday, Wednesday, Thursday, Saturday, Sunday. So if you're asking whether I can start with Sunday, fine. I can start with Sunday. So you can start with Sunday, Monday, Tuesday, Wednesday, up to Saturday. So in our example, please do not write it in this way. You have to write every word. So it must be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So the next one we have is this. They say this is a set of all x, such that what x is an element of what integers. And integers are positive and negative whole numbers. So integers are positive and negative whole numbers. Where x is greater than or equal to what? 5. So numbers that are greater than or equal to 5, that means 5 inclusive, and less than or equal to what? 14. So therefore, we are just asked to list it in this form. I should write it here. The second one, we are asked to list it in this form. T is equal to what? 5, 6, 5, 6, 7, 8, up to what? 14. This will be the end of it. So please recall in an example, write every number. Don't do it this way, please. And lastly, we have that B is a set of all x such that was x is what a quadratic equation. So we have to find the roots of what this quadratic equation in order to determine what the elements of what this set. So firstly, we have that x squared minus 3x plus 2 is equal to what? 0. We need two numbers that if we multiply to give us positive 2. And if we add it to give us what? Negative 3. And those numbers will be what? Negative 2 and what? Negative 1. So you can say x squared minus x minus 2x plus 2 is equal to 0. And we have these two and we have these two. So what's common here is x. We have x minus 1 minus 2 equals x minus 1 equals to 0. Because if we multiply this, we get back to this. So these two are the same. So we pick one. We have x minus 2 in brackets, these two, and x minus 1 equal to 0. So x will be equal to what? If these two, or let's do it this way, minus 2 equal to 0, or x minus 1 equal to what? 0. So if these two crosses over, it will become a positive 2. So therefore x is equal to 2, or if 1 crosses over, it will equal to 1. So the roots of this equation are 2 and 1. So therefore, the set B in your roster method will be 2, 1. Or if you decide to start with 1, 2. Let's do it that way. We have 1, 2. Let's do it this way. So this will be the answer to this. So let's look at one more examples before we head over to the next step. We have another example. We say we use set builder's notation to describe the following set. So now it is in roster method. So I'm going to describe it using set builder's notation. Now for this, we have a set A, which is equal to negative 3, negative 2, 1, up to 6. And we have another set B, which is what? A, E, I, O, U. Now, if you look at this, we have to be very specific when trying to write something in roster method. Now, if you look at this is a set of what? Integers, because they are negative and positive whole numbers. Now, since they are integers, I cannot just say A is a set of what? Integers. No, if I put it that way, it will be an infinite set. Don't worry, stick around and understand what it means for a set of infinite. So, I cannot just put it like that. I need to be very specific and detailed. Now, A will be equal to be a set of all x, such that x is an element of what? Integers. Finally, we have gotten the first step correct. Where this comma will just signify where x will be what? Greater than or equal to what? Negative 3. And what? Less than or equal to what? 6. This will be the answer to the first one. Now, I can write this in another format. I can write this as or, instead of writing negative 3 greater than or equal to, I can write this as, let me not write it, I can write this as 4 greater than x greater than 7. Negative 4. So it was x is greater than negative 4, not equal to negative 4. So that means the number after negative 4 that is greater than negative 3, because negative 3 is greater than what? Negative 4. And less than what? 7. And 7 is not inclusive. So therefore I write greater than what? 7. So that means I'll stop at 6. If I write it in this format, it is still correct. So there are various ways you can tweak this and you still arrive at the same answer. But you need to not fall into this range. Now the next one we have is a set B. Equal to, or mere looking at this, you can call, because the set of B will be very specific, so it will be easier for you to know what is there. So, or sometimes you have to struggle in order to, I won't say struggle, but sometimes you have to pay attention to details in order to know what that set is all about. But for this, you can look at this, we all know that this was vowel with letters. So therefore, I can say B is a set of all x. Sorry, let me use another marker. It's a set of all x such that what x is a letter. Sorry, I say letter, it's a vowel letter. It's a vowel of English alphabet. Write it like this, and this is very correct. So if in order for me to write vowel letter, I mean it's not that specific to me, so that everybody can understand. So S is a vowel. Sorry, I said is a vowel. It's a vowel of the what of the English alphabet. So it's a vowel of the English alphabet. So now let's look at the various terms that we use in what set theory. The various terms we use in set theory. So we'll be looking at the various terms of sets, various terms of set, and I'll be explaining all these terms in depth. The first one is element of a set. From the beginning, all I said was objects or things that make up a set is referred to as elements. So the element of a set is represented by the notation. So whenever I see me use this, it means what? It used to represent element, and it was used to represent membership. Membership. So if I have a set A, which is equal to 1, 2, 3, I can say 2 is an element of A. 2 is an element of A. Another notation is what? This. If I have this, is used to represent non-membership. So I can say 4 is not an element of what? Set A. So 4 is not an element of the set A. So this sign is used to represent membership, and this sign is used to represent non-membership. The next one is the order of a set. Now, the order of a set is what the amount of or the numbers of elements a set has. So the numbers of elements a set has is very much the order of a set. And the numbers of a set, or the numbers of elements a set has is called also cardinality of that set. So the cardinality of the set is what? The order of that set. And the order of that set, or the cardinality of the set is what? The number of elements that set has. It has the general form and the set. So this is how it's written. So if you see this sign, it is trying to ask you what the number of elements that the set A has. So the number of elements that the set A has 1, 2, 3, because of 3. So this is the cardinality of that set. So the cardinality of this set is what? 3. The cardinality of this set is 3. Now we have subsets. So a set within another set is called what? A subset. A set within another set is called a subset. For example, if I have a set A is and another set B equals to 2, 3, we can say B, it is represented by this symbol, right? Like this. This is called your proper subset. We'll get into that, but let me explain this. You can see that B is also equal to A because A has 2 and 3. B also has 2 and 3. So, because of this, a subset can be divided into 2 types. The first one is your proper subset, which is denoted by this sign. And the next one is your improper subset, which is denoted by this sign. But in context, it is not called improper subset, it is also called a subset. These two signs are called subsets, but it varies from where you use them. So I cannot say B is a subset of what, or an improper subset. No. Now, what is a proper subset, by the way? A proper subset is a subset with is a set within another set. Is a proper subset where the main set is what having at least one element that is what different from the subset. So, for example, we have B here, which is a subset of B, by the way, proper subset. Because it is a proper subset because A has at least one element which is different from what is B. So I can have B is a proper subset A. So write this B is a proper subset of A. So this is what proper subset. Now an improper subset will look like this. Let's assume we say, oh, 3 here, I have 1. Notwithstanding that I've been written different box, B is a what? Improper subset, or you can say B is a subset. So these two sides are called subset. But if you want to differentiate them, call this improper subset. So B is a subset of A. You can also write A to be what? A subset of B. They are both the same. So if you see this sign, it's there for trying to tell you that they are equal. So whenever you see this, just recall that okay, this is an equal sign. So therefore, this a what subset A, but they are the same. Now there's something we call a superset. A superset, which is denoted by what? The symbol like this. So this is subset, and this is what? Superset. Sorry, this is superset. Now, if I remove one here, I remove one here, I will say what? A is a what? A superset of what? B. Now look at the power of the set. Now, every set is a subset of itself, or every set has a subset. Every set has a subset. Now, the power of the set is the number of subsets a set can have. And the formula is what? 2 raised to the power of n. So the power of set of an element is 2 raised to the power of n. Or the power of set of a set, the power of a set is what? 2 raised to the power of n, where n is an element of integers and n is greater than or equal to 0. So n can be 0, but n cannot be negative 1, negative 2. We cannot have negative 1 element of set. No. So let's use A as our case study. The power of the set A will be what? 2 raised to the power of n. And we count it 1, 2, 3. So therefore, 2 raised to the power of 3 will be equal to what? 8. So the set A has 8 subsets. Stick around, we'll see how we find the subsets of the set A. Finally, we have family of sets, or we can call it class of sets. The family of a set is a collection of sets. That's what it means. A collection of sets is the family of a set. So let's assume we have set A and set B. We can have another set F, which will be what? A, comma, B. So F is the family or the collection of the sets A and B. And this is what family of sets means. So let's look at examples concerning subsets and power of the sets in order to understand them better. Now we have this example, and we say we have a set A is equal to 2, 4, 6. We should find the cardinality and the number of subsets and list them. Now, first thing is the cardinality. Cardinality is the order of sets. So therefore, write the solution. Number of A will be equal to 1, 2, 3. So therefore 3. This will be the answer to us A. Now for B, So we should find the number of sets and list them. Now, the number of sets will be what? 2 raised to the power of n. So 2 raised to the power of 3 will be equal to what? 8. So we have 8 number of sets. I didn't know that the camera turned on. So I stated earlier that before we list out this set, there are rules I would like us to know about listing the subsets of the set. So whenever you are listing the subset of the set, you must begin with an empty set and you end the set, end with the set you are given. So whenever you are asked to find the subsets of the set and list them out, you must always begin with an empty set and you end with what? The set you are being given. So, in this case, we started with an empty set. Then you start listing them out. You start listing the element, each of them one by one. So we have 2, set 4, and always separate them by commas. Please. 4 and 6. Then you enter 2, 2. We have 2, 4, 2, 6, 4, 6. And please don't write 4, 2 when you have already listed out 2, 4. They are the same thing, irrespective of the format you write. So as long as you are written 2 and 4 in the same set and you have enclosed them, you cannot reverse it. So after I've written that, we had the last one. And you can see 1, 2, 3, 4, 5, 6, 7, 8. So therefore, we have already satisfied this. So therefore, these are the subsets of the set A. Next, we'll be looking at what? The types of sets. So now we'll be looking at the various types of sets. And there are 8 types of sets we'll be looking at. The first 4 will be your empty set, your finite set, infinite set, and disjoint set. Now, when a set is said to be empty, it means that set has no element within it. I mean, from the word empty. So a set is said to be empty when there is no element within that set, and it is denoted by the symbol of, and it is also called your null set or your void set. Your null set or your void set. Now, there is a mistake that students tend to commit. Students like to write your empty set as this is totally wrong because this is not an empty set. If you write a set in this manner, it will not be regarded as an empty set. It will be regarded as a set that has this element within it. So anytime you want to write an empty set, you are meant to write it in this manner or write it in this manner. The next one we're looking at is your finite set. Now, a set is said to be finite if it has what? A definite end. Meaning we know where that set is going to end. For example, if you have a set of natural numbers up to 10, that set will be regarded as a finite set. What do we mean by that? You have a set A which is equal to 1, 2, 3, 4, 5, 6 to 10. Sorry. 6, 7, 8, 9, 10. This set will be regarded as a finite set. So this set has what? A definite end because it ends as what? A number of 10. So that means the set A is regarded as a finite set. An infinite set will be a set that does not have a definite end. So a set that is infinite means that set does not have a definite end. For example, if you say a set of integers, A which is what? X, which is an element of what? Integers. This set will not be regarded as what? A finite set because integers have what? An indefinite end. So therefore the set A is regarded as an infinite set. We say a set of multiples of 9. That set will also be regarded as well as an infinite set because why? Multiples of 9 has no definite end. The next one will be what? Your disjoint set. Two sets are regarded as disjoint if they have nothing in common. For example, if you have a set A, which is what? 1, 2, 3, and you have, sorry, one in bracket. If you have your set, another set B, which has A, B, and C, these sets will be regarded as disjoint because what? They do not have anything in common. If you look at the elements within them, they have nothing in common, so they will be regarded as what? Disjoint set. The fifth one will be your singleton set. Now, a set is said to be singleton when it contains only one element. So, like the previous example I spoke about, when I spoke about empty set, when I say if you write something like this, this is a singleton set and not an empty set. So it was not an empty set before because it is a singleton set, meaning it contains what? Only one element. So if you have a set A, which is what? 2. This is a singleton set. Next one will be your equal set. So two sets are said to be equal if they contain the same members or the same elements, irrespective of their arrangement. So two sets are said to be equal if their elements or members are the same, irrespective of their arrangement. If I have set A, which is equal to 1, 2, 3, and I have another set B, which is equal to 2, 3, 1. These sets are said to be equal because A is equal to irrespective of their arrangement. As long as they have the same elements or the same members, they are said to be equal. And so we can say A is equal to B. Now, if you recall from the subset and when we spoke of proper and improper subsets, we say when we use this sign, it means two sets are the same. So we can also say A is a subset of B, or you can also say B is a subset of A. The next one is your equivalent set. Now, two sets are said to be equivalent if they have the same number of elements, not the same members, but the same number. So that means their cardinalities are the same. So that means the number of sets A will be equal to the number of sets B. For example, if I have a set A, which is equal to A, B, C, I have another set B, which is equal to 1, 2, 3. We can say A to 1, B to 2, C to 3. So they are equivalent. The number of elements in A is what? 3. And the number of elements in B is what? 3. Since 3 is equal to 3, they are regarded as what? Equivalent sets. And lastly, we'll be looking at your universal set. Now, the universal set is regarded as a background set because it contains all the elements that are relevant to a given condition. I'll say it again, the universal set is regarded as a background set because it contains all the elements that are relevant to a given condition. So it is all your possible values for a given set. So all the possible values for a given number of sets you have been given, it is what your universal set that contains every one of them. It is denoted by the symbol. It is denoted by this symbol. So now let's look at the example. If you have the set A, which is equal to 1, 2, 3. You have another set B, which is equal to 0, 5, 6. Your universal set that will be relevant to all the given conditions here, denoted by this will be what? 0, 1, 2, 3, 5, 6. And this will be what? Your universal set. Now let's look at examples concerning all the length in order to understand them better. We are asked these two questions, and we are supposed to find answers to them, obviously. So the first one says find the power set of set A, which is what? A prime factor of 210. That's the first question. Second one says given that y is equal to the set y is equal to multiples of 3 less than 20. Find the number of proper subsets of the set y. Now let's solve the first one. First of all, you have to know what prime numbers are before you understand what prime factors are. So the prime numbers are numbers that can be divided by one and itself only. So factors are factor of a number is a number that can divide that number without a remainder. So I'm looking for the factors of 210 that are prime numbers. That's what it simply means. So the factors of 210 are called prime numbers. Good. So 210, you have to find the prime factor of 210. First of all, just bring 210 out and you split it. 210 can be written as what? 2 times what? 105. 105 can be written as what? 3 times 35. So 3 times 35 will be 105. 2 times 105 will be 210. 35 will be what? 7 times 5. As you can see, these are what? The prime factors of 210. So if these are the prime factors of 210, we are looking for the power set. Don't forget. So that is the set A. Right here. 2, 3, 7, and what? 5. So if we have this, the power set, don't forget, is given by the formula of 2 raised to the power of what? N. Sorry, raised to the power of n. But let me do it here. Power set is what? Power set is what? 2 raised to the power of n. So now n is what? The number of elements. So 1, 2, 3, 4. We have 4 elements. So the power set is what? It will be 2 raised to the power of 4 and 2 raised to the power of this what? 16. And this is what? The answer to the first question. So the second one says that given that y is the multiples of 3 less than 20, and 20 is not inclusive by the way. So if 20 is a multiple of 3, if you know your multiplication table, just go through your multiplication table and you see the numbers that 3 multiplied are less than, and just your answer are less than 20. So to get this will just be 3. 3 times 1, 3. 3 times 2, 9. 3 times 4. 3 times 3, and 3 times 1, 3. 3 times 2, 9. 3 times 2, 6. Sorry, 3 times 2. That's 2, 6. 3 times 3, 9. 3 times 4, 12. 3 times 5, 18. 3 times 6, 18. And this is what we stop. So this is the set Y. Now the social find the proper subset. So the number of proper subsets. Now, the number of subsets, P, we call your power set. They're asking for your power set actually. So your power set is 2 raised to the power of 9. Now, your number of elements is what? 1, 2, 3, 4, 5, 6. Which is what? 2 raised to the power of 6. And 2 raised to the power of 6 is what? 64. Now, this would have been your answer if they are asked for the number of subsets. But they say proper subset. Now, what they mean by proper subset is, recall in the rules of finding a subset, you begin with an empty set and you end with the set itself. Now, the set itself is not a proper subset to the set, rather it is an improper, which is it is equal to the set given. So that means it will be what? Minus 1. So therefore, the final answer is what? 63. And this is the answer to the second question. See you in the next video. Thank you very much.